Well, good morning, everyone. Thank you for joining me today. I'm actually in Texas today, so I'm definitely working remote today, out looking at some jobs. So uh, took a little time out to do this little webinar today. It's not a real long webinar. I'll probably keep it it's about half hour or so. And it's basically we're going to go through and how to troubleshoot a compressor, to see if it's a, compressor or it's one of the components in the compressor. Uh, So as we go through this, it's just me today. I don't have a host. So if you have questions, feel free to either raise your hand or type out the question. And then when I get to a stopping point, I will answer those questions. At the end, there'll be my email address and tech support email address and phone number. So if you need anything, you can definitely email me or technical service with any questions. This webinar will be recorded today, and this afternoon it'll wrap everything up, and you can go and check out the recording on our YouTube channel. It's Intertech University is the YouTube channel. All of our webinars that we do now are recorded, and all past webinars are on our YouTube page as well. So you can subscribe to our YouTube channel, and then it'll update you when we get new videos and things, and you can put them in your library. So it's a good, nice little tool that we've started using since we've been doing mostly webinars at this point. So if you have any training needs that you're looking at, feel free to reach out to me either by email or you can call me directly, and we can, do a webinar. Depending on the situation, we could possibly do an in-person training. It just kind of depends. We'll have to kind of discuss that, but feel free to reach out to me and we'll go ahead and get started. Thanks again for joining today. So this is me. I'm John Pendleton. I'm the senior trainer and I'm also in tech support as well. The first phone number, that's 618-690-3275, is my desk phone directly to me. So if you need anything, again, feel free to reach out. The 664-5860 is the tech support group line. So if you call for tech support, you can call that number and it'll directly ring back to the technicians we have in technical support. We actually have a few guys, excuse me, all of our guys basically work remote now, except for me. But I work remote part of the time. I'm just in Greenville. We've got Tom Einhorn in tech support. He's in Effingham. We got Jim Strandlin, and I think he's with us today, and he's up in Minnesota. We have Kip Westrom, and he is in, I believe, Wisconsin or Minnesota. I can't really remember, to be honest with you. And also Rob Shawless, he's our hydro heat guru, and he's in Pennsylvania. So we've got a lot of knowledge in tech support, so don't ever hesitate to give us a call, especially on a compressor. When you are replacing a compressor, a lot of times we'll send you a warranty analysis form if the compressor was under warranty, and we'd like to have that filled out completely and returned to us. So when you're on the job replacing that compressor, we know that the compressor has failed, so we don't need it on the old compressor. We would like the information on the new compressor that you install. And then, if you don't know exactly what to fill out, we would rather have you call in into tech support and have us give you a hand than you send that form in and then we need more information and we need you to go back out. That's kind of a hassle for you guys, I know. So any questions at all on that form, reach out to us. That's what tech support's for. So don't ever hesitate. Don't feel bad if you don't know something. You're always learning and learning new things. So don't ever hesitate to reach out to us. That's what we're there for. So we'll go into some compressor motor troubleshootings. A compressor is normally a symptom. So we need to find the cause of the problem. Obviously, if the compressor is not running, there's not a whole lot we can do as far as run testing it. So we'll have to put a new compressor in and then try to find out what caused that problem. If not, we're going to start having we could have numerous compressor failures. and that's not a good thing. So we're just trying to eliminate as many, problems as possible and, callbacks on systems. So basically we have two types of compressors. We do have single stage scroll compressors, and we have two stage scroll compressors. So they're all Copeland scroll compressors. There's one type of different compressor on the horizontal unit, and it's got a rotary compressor in it because of the size of the cabinet. You can't really stand that compressor up. So it's kind of a smaller laid down type compressor, and that's the only compressor that will not be the Copeland scroll. It's I'm not even sure what the brand is, but I know that it's a rotary compressor in that. Basically on any type of scroll compressor, there's no real starting devices. Now, you may have a soft start on there to lower amp draws on initial startup, but we don't have any starting capacitors or starting relays on these Copeland compressors. There is a run capacitor on it that if the run capacitor is bad, the compressor is not going to operate. So that's the only part to the compressor that, besides a contactor, it really needs to be operational for the compressor to operate. There's no special controls for the compressor, and basically they're a high efficiency compressor. You've got two scrolls inside that compressor. You have one stationary and one that's orbiting. So the orbiting kind of moves around and forces that refrigerant into a smaller and smaller space and compresses that refrigerant. Every once in a while, we'll have the stationary scroll in shipping will sometimes be damaged, I've seen, and it'll sound a lot of times like there's gravel in the compressor where those scrolls are knocking together. A lot of times that's due to vibration during shipment. If it starts out, an initial install. That can also happen when the unit's running under adverse conditions. So it could also be caused by the operation of the compressor. The two-stage compressor, the only thing really different about the two-stage compared to a single-stage scroll is we have unloaders. And if you look at this picture to the right, you can see the two scrolls and you see those two black dots. Those two black dots are the unloaders. Basically, it opens those up and dumps the refrigerant back into the suction of the compressor. So when you run in first stage, you will actually see higher pressures than what you will see in first stage. So we're running about 67% capacity in first stage, so about 2/3. We run more in part-time, part load, and that's where we really gain our efficiencies and run a much better rate on the unit. So and it will shift on the fly as far as going from first stage to second stage. You can actually, if you want to know if it's switching back and forth, you can unplug the harness for the second stage solenoid and look at amp draws. And we'll kind of cover that here as we go along. The scroll is pretty reliable. Normally, if it fails, there's something else going on in the system. Now, I'm not saying that compressors don't just fail, a motor or something like that, but usually there's an issue behind that, whether it's shipping damage, it fell over in shipment, or it could be too that just wasn't made quite properly. But normally there's going to be an issue, whether it be refrigerant or water flow, that's causing the compressor to run higher amp draws and running hotter than normal, things like that. Again, no starting components, no special controls, and it's ultra high efficiency. There is a Copeland compressor video. I'm not going to play it today, but it just kind of shows those orbits or those scrolls orbiting and how the refrigerant passes through. And you're more than welcome to check that out. It's on YouTube, and it's just a Copeland scroll compressor video. Basically, there's two possible issues when a compressor fails. Either the compressor does not run or compress refrigerant. So, that could be either electrical or something mechanically wrong inside the compressor itself. And you could also have a compressor that does not shift to full capacity. Easiest way to tell if it's not shifting to full capacity is amp draw. Sometimes you can hear it, sometimes you can't, just kind of depends. But we'll cover how to check that here in just a minute. So if the compressor doesn't run, it doesn't operate, it's not, there's no amp draws on the compressor, the contactor may be pulled in or not, but it's not running. So the first thing we're obviously going to do when a compressor is not running is we're going to look for line voltage at the contactor. Obviously, if there's no power there, we probably don't have a status light on the lockout board. That's usually a good indication that there's no power coming into the unit. So check the circuit breaker, obviously check your voltage coming into your contactor. If the circuit breaker is tripped, leave it off and ohm out the compressor. We'll cover some ohms of the compressor here in just a minute as well. You can disconnect the thermostat. We do have that removable terminal strip on the unit. So you can remove that and you can use jumper wires, or you can go to the thermostat. It's not, not that big of a deal, but we want to make sure there's a call to the unit at Y1. So make sure there's a Y1 call and make sure you have a green status light on the board, unless it's in test mode. If that lockout board, if you pulled the test jumper, or some of the boards have the dip switch, if you flip that out, that status light will go out, so you won't have it. You can also feel the compressor. If it's hot, you can ohm out the windings and it could be open. If it is, it'll have to cool off. Now, if this was a condenser, with the compressor outside, we can take a garden hose and kind of cool it off. We can't really do that in a home. So, there's a couple ways you could do it. If it's in a basement where it's on a concrete floor, you're not worried about getting water on it, then it's not really that big of a deal. You could also get some bags of ice or something, but if you in a space where you just can't get water on it, then you're probably gonna have to shut the unit down. I'd probably pull the disconnect or flip the breaker and just tell the homeowner that you'll be back in maybe a couple hours. If it's late in the day, you may just have to come back the next day. It's gonna take a while for that to cool back off. If it's not hot and it's in overload, the internal switch inside of there could be bad. And if that's the case, it probably got hot one too many times. It's just a little bimetal disc inside that compressor. And so over time, it's going to get weak as well if it gets tripped too many times. So you can ohm out the compressor and see if that's open. And if the compressor's not hot and it's open, sometimes you can smack the top of it with like a rubber mallet on the compressor, and it'll sometimes reset it, but it'll probably trip again. So if that's the case, there's not a whole lot we can do. If the internal overload is stuck, then we'll have to replace the compressor and then look at why the compressor is overheating. This is basically a jumper that if you actually contact me, my email, I can send you one of these removable terminal strips, just the bottom portion of it, and put a couple wires in there, make a little jumper for you. So just shoot me an email and I can send it over to you. It's not a big deal. But basically, we just use this so we don't have to worry about, running up and down the stairs. So it never fails. You give the thermostat a call and you wait down at the unit for what seems like an eternity. And then about the time you walk up to the thermostat, it kicks back on. So sometimes it's just easier to jumper it out, pull the test pin or flip the test jumper and speed up the time delays and not have a time delay from the thermostat as well. So you basically just need a G, a Y, Y2 if you've got a two-stage unit, and the R, and we'll just jumper all those together. If you've got a water-to-water unit, you don't need the G, obviously. There is no fan on a water-to-water unit. So if the breaker is tripped, do not reset it yet. With the power off, check out all the wiring, pull the harness, the high voltage harness off the compressor and make sure it's not. Sometimes those pins will get real hot and they'll break. Sometimes it'll even dump refrigerant out those. And but pull that harness off, make sure it's not melted anywhere. Replug it on there, make sure the electrical connections are tight. Look at your capacitors and your contactors. You may have to take the cover off the contactor and make sure that the points are and the contacts are still good. there's no spider that's built a nest in there or something like that. So I have seen sometimes where you take that middle black cover off and then the spring and everything kind of come back at you. They're hot or is weak and it broke. So definitely take that little cover off so you can see down in there and look at the contactor. Again, look at the compressor harness and the compressor terminals. Look for any excessive heat or any burning of those terminals. And also you can go ahead and check for a grounded compressor. Resistance should be infinite. If you're showing any resistance to ground, then the compressor is shorted to ground and your breaker is more than likely tripped. So a shorted compressor winding, checking at the ground. Basically, you can check each terminal and check at the ground. If you check it like on the compressor, make sure you kind of scratch that compressor so you get through the paint and you're getting on metal of the compressor. You can also ground it to the suction line right on the compressor. And this reading on the ohm meter here is 0.2. That's showing resistance, showing at the ground. This would be a shorted to ground compressor. Make sure you check each winding to ground, because it could be the start windings grounded out and not the run winding. So check every terminal, all three of them. If the breaker's not tripped or the windings are not grounded, we'll go ahead and move on, and we're going to leave the line voltage off still. Measure the resistance of the compressor windings across each other. Measure the resistance from run to common and start to common. If both readings are infinite, then the compressor is in internal overload and it'll reset when the compressor cools. If it's not hot, once again, it could be it got hot one too many times and it will not reset. Again, you can and it may reset it, but more than likely it'll trip it again. So don't just reset it and walk away. Definitely run the unit and see what's going on with it. If it is hot, like I said, if it's in a space where you can get some water on it, go ahead and run some water over it, put some ice bags on it or something. If not, you just have to wait for it to cool down. So measure run to common and start to common. So if you get this and this, it's in internal overload. So it'll say OL. Mine doesn't have OFL. Mine says OL on the meter. If you get that reading there, then it's in internal overload. I do have this, these kind of winding readings on a little troubleshooting sheet. So once again, if you email me and request that, I can send that to you. If you just tell me today, I'm not gonna lie, I won't really remember. So it's easier just to track. If you just send me an email, I can send you a PDF of it. I can even send you a PDF of this training if you'd like as well. So don't ever hesitate to reach out to me. So if any windings are shorted to ground or open, the compressor is dead. If the windings are shorted, always check the system for acid in the system. We do have acid test kits now. This like a little checkmate. You just put them on the refrigerant line. It takes like 2 seconds to tell. If it does have acid in it, please do an acid cleanup. If you're not sure how to do an acid cleanup, we do have a tech bulletin on how to do a compressor burnout cleanup. Or if you have any questions, again, call tech support. That's what we're there for. If you don't, that acid's going to stay in the compressor, in the refrigerant circuit. We're not going to be able to get it all out. And then it's just going to eat away at the new compressor, and we'll have another compressor failure in, another year or so. So we've got to make sure that we're doing the right thing, putting, acid cleanup cores in, things like that. So when you ohm out the windings on the compressor, you'll do 3 ohm readings. You'll do common to run, common to start, and run to start. So common to run should be your lowest value. You can see in this picture here, we've got 1.1 ohms. The common to start should be your middle value, which we're showing here at 3.2. And then run to start is your highest resistance value. We've got it here at 4.3. Normally, your common to run and your common to start, those two readings, so 3.2 and 1.1, will normally equal or be very close to the highest value or your run to start. So you can see here, 3.2 and 1.1, that's 4.3 ohms. So that's what we're seeing on the run to start. Now, it may not work out exactly, but it's going to be pretty close. And you should have, your resistance should be minimal. If you've got 500 ohms on start to common, then we've got a problem with our compressor. So they should have resistance, but it shouldn't be real high. Obviously, if you get OL, then it's shorted. So you should have some resistance. It just should not be high. Make sure you check voltage at L1 and L2. You can go ahead and pull that molded plug off with the breaker off now still and leave it off. Go ahead and give the unit voltage, so turn your breaker back on. Obviously, if the breaker immediately trips with the high voltage molded plug from the compressor removed, then there's probably something in the wiring that is rubbing, maybe a copper line somewhere, but you've got a direct short to ground and it's in the wiring somewhere because we're not hooked up to the compressor itself. So with no call for heating or cooling, check voltage to the contactor at L1 and L2. Obviously, if you have 208 volts, it should be somewhere near there. Same thing with a 230, plus or minus about 10%. If there's no voltage, check your field wiring and check your connections from your panel and check that breaker in the panel. You could have a couple different problems going on. The compressor could have tripped the breaker one too many times and the breaker in the panel is weak. So make sure you're getting power out of the breaker. I've seen that a few times where the breaker's actually bad, put the new breaker on, and then the compressor was probably what caused it, but make sure you check the breaker in the panel as well. Go ahead and place a call for heating or cooling. You can do that with the thermostat or the jumper wires. And again, make sure it's in test mode so we're not waiting on that 5-minute delay. And see if your contactor closed. If it did, make sure you check the T1 and T2 at the contactor to make sure you've got proper voltage, that we're not dropping a leg through the contactor, because that'll cause the compressor to overheat real quick if you give it 120 volts or 110. You're only getting one leg of power, so it won't take long for it to overheat. If the contactor did not pull in, obviously check for 24 volts from the contactor or to the contactor. If there is 24 volts to the contactor, then you can, obviously the coil in the contactor is bad and you'll need to replace the contactor. If there's no 24 volts, you'll want to check trace it back. It goes back to the lockout board. Make sure that your safeties are all closed. It's very possible that a light could burn out on the board and it's showing and it's really in high pressure or something like that. So always double check to make sure that the high pressure, low pressure switches are closed. If you've got a flow switch, you could jumper that out and make sure that circuit's good as well. But just make sure you've got to have 24 volts obviously to the contactor. So it runs basically from the thermostat to the lockout board. Make sure all the safeties are closed and then goes to the contactor. If the contactor pulled in and you have voltage at T1 and T2, make sure you check the capacitors. We don't have a huge issue with capacitors, but they are what they are. They bulge and break and drip oil all over the place sometimes, and they're nice and stinky. So definitely check capacitors and check for proper voltage to the capacitor and also check and your microfarads of the capacitor. Make sure it's usually like 5%. It needs to be within 5%. Sometimes it's 10% depending on the brand, but make sure you've got the proper capacitor and that it's functional. Make sure you check the high voltage harness on the compressor and make sure you got voltage in through the plug there. There could be something wrong internally in the plug, so make sure you've got voltage there. If you do have voltage, go ahead and reconnect the harness and we'll move on to the next step. Obviously, test your capacitor. If the meter reads OL, the capacitor is open and will need to be replaced. The capacitor is good, run the unit and check run load amps. Make sure the compressor is not pulling lock rotors. We do list lock rotor amps in our manuals, and it's usually 5 times of what run load amps are. So it's normally somewhere around 125 amps. And some meters you can't really read it because it's really quick. I've got a meter that will read it and will kind of hold the inrush on there. And so sometimes you got to have a special meter, or you got to look really quick because it won't last long. If the run load amps are within specs, normally I'm just going to say, let's say a 4 or 5 ton unit, the run load amps are going to be somewhere around 25, 27. Now, if you guys have taken amp draws quite a bit in the field, you know that we're normally not at the run load amp mark that we put in the manuals. We're usually, considerably under it, 3, 4, 5 amps below it. That's not uncommon. So as long as we're within specs, the unit could have overheated and reset. So we're going to have to check the refrigerant circuit. If it is pulling lock rotor amps, double check the voltage and the starting components. If those are all good, then we're going to have to replace the compressor. Once you replace that compressor, again, we will send you a warranty analysis form. I think Jim Strandland's here with us today, and he can attest to this because he goes through a lot of those, as well as I have as well. We get a lot of information that is useless, or there is just not the information we're looking for on there. So once again, we need that information. We hate to call you and have you go back out, but we will, because we need it for warranty. It's not, yes, we're trying to solve a problem, but we also have people that we have to answer to. So if we have numerous compressors, people are going to start asking us questions. If we have a completed startup form, then we can show it and say, here, this is the information they sent us. Everything looked good at the time. So it's really a savior for you and for everybody involved. We're just, in tech support, we're just there to try to solve a problem. And, anybody can just go in and replace a compressor and move on. It's the people that can go in there and find out what causes the problems that are really doing, their customers just, right. So we're just trying to get to the bottom of a problem. If we call you and ask you for information, please don't take it out on us service technicians. We're just trying to get to the bottom of the problem. We're not trying to question your abilities or anything like that. We just have to get answers. So don't feel bad if we call you. We do it to a lot of people. Compressor mechanical failure, bearing seize, it could have loss of oil. We had somewhat of an issue back in the day with some of the water-to-waters running them at really high water temperatures and having some oil return problems. And we put some oil separators in and things like that. So obviously we've got to have oil in that compressor. It's a motor and it will overheat and burn up if you don't have oil in it. When the bearing seizes, the compressor, the breaker will normally trip, but it's going to pull that lock rotor amps. That's what's going to happen. 3-phase units, they're going to run backwards on a scroll. And if you ever seen a compressor run backwards, and you got really low pressures, low amp draws, it sounds crazy. And it's just not doing any work. It'll end up overheating is what will happen. So on a 3-phase unit, make sure you got your phases in balance there. And So make sure you're checking that. Check if you do have a bearing seize and you're tripping the breaker or you're shorted to ground, always check for acid in the system. Again, we have those checkmates. Most supply houses have them. You know, they're coming a little single use. You can even, you know, after you've checked it, you can send it in with the warranty analysis form. And if we ask for the compressor back or something, send it in with it. You know, tape it to the side of the compressor. That way, if we need it, we have it. You could have the main stator shaft is fallen, or you know, is seized up, or it. A lot of times, again, that's the non-orbiting scroll. That's the stationary scroll, and it could have been shipping damage. We have that occasionally. East Coast is real bad about shipping damage, and some in southern United States, sometimes we have some damage there as well too. But East Coast is real bad. I don't know if the truck drivers are just driving like Mario Andretti or what they're doing, but we have seen some damage on scrolls. We do run all of our units before we send them out. So normally, if it comes from the factory, it shouldn't be that way. They normally will check and hear that kind of thing. So something could have happened during shipment. You know, things happen. We do run tests to try to eliminate as much as possible, but you know, things happen. I know it does suck on a brand new unit when you go to start it up and the compressor's rattling around. So again, things happen. They're out of our control. So just let us know. We'll take care of you. Intertech's real good about taking care of the customers. The shaft could be broken loose from the scroll. It'll run, but it'll usually overheat and go out on internal overload. And the pressures on the gauge are either equalized or pretty close. We really just don't have any compression. Amp draws, you know, if it's a 4 or 5 ton unit, amp draw actually will probably be like 4 or 5 amps. Normally we're about 15, 17, somewhere around there. So that's a pretty good indication that it's not pumping. So we also have the compressor is not shifting. So if the compressor is running, but it's just not shifting, basically we can confirm that with amp draw. So it should raise 3 to 5 amps, or about 33% of the total amp draw. You can also make sure we've got voltage to Y2. So measure between common and Y2. You can measure it on the ECM board or at your, you know, you should have it if you've got your jumper on there. Basically, it comes from the thermostat terminal strip and goes to the ECM board and then leaves there and goes to the different components, lockout board, things like that. But so you can check it at the ECM board on those little screw terminals. It'd be close to 24 volts. If you do have voltage there on the ECM board, you can remove the compressor low voltage harness. It'll have 2 blue wires on it. That's going to indicate the low voltage harness. You can remove it and you can check that plug. Now that plug, it's AC voltage coming into it and it's DC voltage out of the plug to the compressor. So if your meter switches from AC to DC, you won't even really notice it. But if you have a meter that you need to switch, then you have to switch it to DC. There's a rectifier inside that little black molded plug, and it switches it from AC to DC volts. If you have AC voltage at the ECM board, but you don't have it out of the plug, then the plug is bad and it'll have to be replaced. At least in that situation, the compressor will still run in first stage. It's not the end of the world. At least they'll get some cooling. They may not be able to keep up, but at least they'll have some cooling for them. If you have voltage, you can reattach it to the compressor. If the compressor still does not shift, you can you'll have to replace the compressor. There's no replacing the second stage solenoid. It's internally in the compressor, so you'll have to replace the compressor on that. The unloader, which is basically that low voltage harness on the compressor, if you want to test it, you can operate the system and cycle the unloader on and off. And again, the amperage should go up or down. You can also jumper, just remove the call for the compressor, so you can kind of hear, you don't have a fan running or the compressor causing noise. Just jumper R to Y2 and listen for a clicking sound at the compressor. And you can, do that a couple times, and that should energize the solenoid inside the compressor. So you can try to maybe get it unstuck by doing that, and then you can start that compressor back up and see if that works for you. If not, obviously, we're going to have to replace the compressor itself. You can also check the resistance on that molded plug with the, the resistance on the solenoid in the compressor. Basically, that resistance on that solenoid on the compressor itself should be about 32 to 60 ohms, depending on the temperature of the compressor. So the hotter the compressor is, the higher the resistance is going to be. If it's outside of that range, obviously there's something wrong inside of the compressor, and the compressor will have to be replaced. This is that molded second stage plug. And again, it's AC voltage here, coming in on those blue wires, and then it's DC voltage coming out of that plug. Inside of there, where those little dashes are on the plug, there's a little black rectifier. If anyone's like me, I'm always curious about what things look like and such. So when I started at Intertech, I cut one of these apart just to look at it. It looks like a little black box. There's not really much to it. It's not really that exciting, but I did take it apart and look at it. So, but yes, DC voltage out, AC voltage in. There is a compressor troubleshooting video online as well. Those are actually my hands. I'm the new Intertech hand model. So you can definitely check out the video on YouTube if you need, if you want to look and see what a meter looks like when we're ohming out a compressor and checking at the ground, things like that. So with that, I believe that's all we basically have today. If you have any questions, feel free to reach out. I'll hang on here for a few minutes. If not, thanks again for joining. I do have a webinar next week, same time. I will be in a different place, but hopefully, I don't really think I want to be down here. I'm ready to go back home. The COVID kind of puts a damper on traveling and stuff. So, but I will be back in Greenville next week. So if you need anything, I'll be back in the office on Monday. Feel free to reach out. And looks like we got a question. Oh, you're welcome, Jason. Thanks for joining, and hope to see you next week. I can't exactly remember what the training is for next week, so I apologize, but definitely check it out. You can go to Intertech University, or you can also go to intertechusa.com and click on Intertech University and register. Again, they're all free. So, and if you missed one, check it out on our YouTube channel. So thanks again, guys, for joining me today, and have a wonderful day. Oh, Jason let me know that next week is ECM board testing and setup. So thanks, Jason. I appreciate it. Thanks, Vaughn. I appreciate it. I have 15 this morning. Not too bad.
Oh, really?
Yeah.
Oh, cool. Yeah, I just went to your website and